So, yeah, it's April 27th. 4/27. And today we start factoring quadratic trinomials. If you were to go on the internet, like on YouTube, you could find a handful of different explanations of ways to factor quadratic trinomials. And that's might be something that you embark on of your own free will over the next couple of weeks. If something isn't clicking right, then maybe you'll just take it upon yourself to say, I'd like to find a different way to try to do this. So, you know, there's all these dorks like me that make videos, and you might find a method somewhere where you go, oh yeah, that's the one for me. I have two methods that I use when I teach this. And one of them is what I call the brute force method. It involves no fancy drawings or diagrams or anything. It's just try it until it works. And so I'm going to start the lesson with this approach. And what I'm going to ask of you is, I'm going to ask you to factor something, and you may not know what that means yet, but I'll show you. There's going to be a math problem in here. It's going to be a binomial times a binomial. And rather than give you the math problem, I'm going to give you the answer to the problem. And this is, I can officially now say, welcome to the rest of your math life. This is what factoring is all about, is the act of taking something that has already been multiplied together, something that is an addition or a subtraction problem, which clearly what I have written up there is, it's something plus something plus something. That's called an addition problem. And what we want to do is factor, and factoring is the act by which we turn something into a multiplication problem. So if we know what we're doing, if we're able to navigate this little minefield here, when we're done, we'll have a binomial times a binomial that if you were to hand it to your neighbor and they multiplied it out like we've been doing, and you're so good at it, I saw it on you, you're so good at this. If you handed what you write to your neighbor, when they multiply it out, they would get 3x squared plus 10x plus 8. So I task you with this, and I'm not just going to completely hang you out to dry, but be curious to see what would be maybe the first observation that you would make. Luke? What do you think it is? So let me refresh your memory on something here. One thing, and I'll get back to you guys that had your hands up in a moment. Based on that answer, I feel like I need to say this. What we've been doing a lot of is multiplying things like this. I'll remind you. So this is where your brain should be going, is thinking about, oh, so my teacher's asking me to write one of those multiplication problems, right?
Like binomials, it has to have something x, or it just has to have x.
Yeah, it's going to be like 5x plus 1 times 3x minus 2 or something like that. Because again, if I had you multiply this out, I don't hesitate to even say that you can do this. You've been doing this so well for so long. So this would be 6x squared minus 2x minus 20. Right, I skipped a little step there, but you know how to do that. So the idea is, if I had put 6x squared minus 2x minus 20 on the board and said, I'd like you to write the math problem that would create that, then the answer that you would eventually arrive at would be, oh, I got this. It's 2x minus 4 for the first binomial and 3x plus 5 times for the second binomial. You with me? Does my expectation seem clear?
One of them has to be 3x because you
Yeah, the first one would have to be 3x.
What do you think, Coop? Yes.
That's all we need.
Good. Let's stop right there. And I've heard this now from 3 different places, and this is beautiful. Every time I hear it, I'm enjoying this. I know for a fact that in order for this to work, If someone writes me a math problem and I'm going to make 3x squared, I need one of those and one of those. Like, think about your journey. If you set out to do a multiplication problem, the very first thing you're going to do is multiply these two things together. And 3 is what we call a prime number. So it's not like we have to sit around and wonder, I wonder if it's this. And we know the only way to make 3 is 3 times 1. So we need 3 x's times 1x to make our 3x squared. Before I address what you want, I know you want to give more input on this. Does anyone have any questions so far about that? Okay. What you got, Coop? I couldn't agree with you more. Is there any room for a minus anywhere in my answer? No, if I stick a minus anywhere in there, the whole thing goes to poo, because somewhere I'm gonna have to multiply a negative by a positive or something. And it's just, so I agree wholeheartedly with your assessment that there's gonna be a plus sign here and there's gonna be a plus sign here. We're just constructing. This is my favorite method of factoring, by the way. This is all I do. It's a brute force method. I don't sit around. I'll show you how to like draw the cute little X's and stuff. It's fine. But the way I like to factor is just get in there and try stuff till it works. And once you get good at this, it doesn't take long at all. You got the answer for me? Okay, so I agree that this is where factoring gets interesting. This is I don't know if I fail at explaining this or if my students are just really proud and don't like. You need right now to accept the fact that you're going to fail at factoring way more often than you're going to get it right. Okay? You need to know that failure is part of the process. The first thing that I think that Cooper is thinking about is he says, whatever I put in this blue box and whatever I put in this blue box, they have to multiply to make 8. And again, I don't want to move on. Don't worry about the 10. That's going to be the big question. What about the 10? The 10 can just wait his darn turn. To be a good factorer, we think about, first off, I got to make 3x squared. Done. And then I think I got to make 8. And here's the rub. There are 4 ways to make the number 8. There's 1 times 8, 2 times 4, 4 times 2, and 8 times 1. And if you don't think those are different, you're wrong. Think about this. The first thing I heard Cooper say was, I need a 1 and an 8. And this is part of factoring. Make sure your pencil has a good eraser. If you put a 1 and an 8 in there, it's fine. It's not right, but it's fine. Experiencing this failure is what makes you start to realize how to get quicker. And I know, and you probably already see it too, that this does not work. And let's talk about why. I know you do. Hold on. So let's talk about why this does not work. If I were to multiply these two things together, what do I get? I get 1x. If I were to multiply these together, what do I get? And you would agree with me that if you add 1x and 24x, you are not getting 10x. Is that correct?
Yeah.
Which is fine. Embrace the failure and accept it. This is the part I suck at. I need to convince you you're going to make mistakes, but they're not unrecoverable mistakes. They're not the kind of mistakes where you turn in your paper and get an F. They're the kind of mistakes where you flip your pencil over to the eraser and you say, well, boo-hoo, 1 and 8 is not what I was looking for. Is that clear? Embrace that feeling and that understanding that you're going to miss. It's fine. So what's another combination of numbers that I could multiply to make 8? Let's try 4 and 2. Let's put 4 here and let's put 2 here. I hear this question sometimes, again, even from Algebra 2 students. They go, what do you mean by check it to see if it works? Oh, I gotta do better. By checking it to see if it works, what I mean is take those 2 green upside down connectors that I have and multiply them together. I'll be asking this of you for the rest of this year and when I see you again in Algebra 2. When I say check it and see if it works, this is what I mean. What are the 2 closest to each other make? What are the 2 furthest away make? Add those together. We did it. Jackpot. The process of factoring can be messy. Okay? I'm going to put another one up on the television now, and this one I'm going to try to help you a little bit less. I'd like to see if you guys can get in there and figure out the combination. So you just did something called factoring. You took a trinomial and factored it into a product of binomials. That's the first of about 1,000 that we're going to do. So next one. So you understand that I'm asking you to write the binomials that, if multiplied together, would equal what I have. I know you do, but you're going to have to wait. I can tell from Alyssa's body language that she has it. I can tell, I know that Cooper has it because he told me so. Anyone else think they've settled on an answer? That's 3. You think you got it, Seth? That's 4. Tyson, you think you got it? That's 5. Sasha, 6. It's there. And by the way, for a while, for the foreseeable future, I'm not going to toy with your emotions. There are certain types of polynomials that cannot be factored. A lot of them. We call those prime polynomials. I'm not going to give you any of those yet. So rest assured, unless I make a mistake, I'm not going to purposely put something in here and trick you. If it'll be factorable, it's there. You just got to find it. Corbin, what did you get? I love this answer. Did you get that, Coy? Nice job. How many of us got that? Just out of curiosity. Nice job. You ready to step it up just a little bit? Just a slight bump in difficulty? You feeling it? Okay. The number in front will be prime. I'm not, we're not to that part of the lesson yet. So the 5 in front, if that's what you're referring to, is a prime number. 5x squared plus 11x. Watch out, here it comes. This is it. Welcome to the trouble. Minus 12. You knew it was coming. That's a big deal, huh? So allow me to get in your way for a second here and point something out. Just before you spend too much time on a fruitless wild goose chase here, to be a good factorer, you always want to take advantage of the things that you know. Know. K-N-O-W. Not think, not pretty sure, but that you know. And here's one thing I and we know. We know that there has to be a 5x and a 1x, right? We also know that the number in back says negative 12. And we know from lots of years sitting in math classes with people like me, that if you're going to multiply two numbers together, so let me underline them in blue for you. If I put a number here and a number here, and I eventually in this process have to multiply them together to get this, what can you tell me about those two numbers? One of them has to be a negative. Could they both be negative? No. Be amazed how often people can make it through a year and a half of algebra 2 and still not even know what I'm saying here. If that number in back is negative, and I'm not talking about the 11 in the middle, I literally could not care any less about the 11 in the middle. I'm talking about the 12 in the back. And if he's negative, then without a doubt, one of my signs has to be positive, one of them has to be negative. Now, I'm not entirely sure that I have them in the right order. That's okay. I just want to write that down. I want to write it down. I want to write down a plus and a minus and commit to that because I know that there's no other way to multiply to make negative 12. Now begins the process of going through all the numbers you know that are called factors, the factors of 12, the things that multiply to make 12. And there are 6 possible combinations. There's 1, 12, 2, 6, 3, 4, 4, 3, 6, 2, 12, 1. Right? Not really. I see what you're saying, but you'll see something here. Well, I'll hold that thought. Anyone want to try something? Why not? A good factorer will do exactly what Luke just did. I can already tell Luke is going to be a great factorer. He just YOLO'd that sucker. Did you say 4 and 3? A good factorer will do what Luke just did and just say, consequences, I'm not worried about it. I'm just going to say 2 numbers that make 12. Don't sit around and beat yourself up. Just pick them, go. This is a good learning opportunity for us. Something's going to happen here that is massively important. We never, ever, ever want to waste our time checking 5x times x because we know that's right. We're not dumb. We put them there. We know they make 5x squared. And I don't want to waste my time checking Luke's 4 times -3 because I know that that makes -12. That's never what this is about. And I think you guys have already figured this out. It's about these 2 green things. You want to get those in your notes and get those in your brain. To be a good factorer, you must understand it's the greens and how they play together that determines, did I get it? What do the 2 in the middle make? What do the 2 on the outside make? Yeah, and it's now that you start to learn more about me and why I get so fired up when people say, oh, that's 15, right? We got to be real perfect and tight. Because if you get a 4x and a -15x and you add those together, what do you get? You get -11x. And this goes back to Cooper's question about, well, couldn't there be? Not really, Cooper, because what happened just now is we got -11x and we wanted +11x. There's a real quick fix. What do you think it is? You switch only the signs. You do not move the 5x or the 4 or the x or the 3. They all stay where they belong, but you switch this to minus and plus instead of plus and minus. And then the dynamic of it, it has no choice but to work out now to be correct, because instead of working with a 4 and a -15, we have a -4 and a +15. Jackpot. Got it? Okay. You'll hear me use the following expression, and I want you to know what I'm talking about. When you come up and ask me about a factoring problem, I'm going to ask, have you at least built your shells? And I just don't know why. I just decided years ago to start calling these shells. And so I refer to that as building the shells. At least I've got the shells there, so I have my workspace, right? And again, like I said, take what you know and run. There's something I know. What goes in the beginning of each of my binomials? Yeah, I don't think it. I know it. And tell me about my signs. They both have to be positive. That is not up for debate. And this is the part where no math teacher can give you some magic formula. No matter which method on YouTube you look, you find all these different funny math teachers. Eventually, in every one of these, there comes a point where you have to go through a process of finding 2 numbers that do this and do this. It's I don't want to call it a guessing game, but inevitably that's what this comes down to. So I'm assuming you figured out what the numbers are. What'd you come up with, Erica?
I got 9 and 4.
Those are my guys. Good job, Erica. X plus 4 times x plus 9. And again, I know x and x make x squared. I'm no dummy. I know 4 and 9 make 36. That's not what I'm interested in. Good job, Erica. What I'm interested in is this beautiful combination. 4x, 9x, jackpot. Of course. And in a case like this, order is interestingly irrelevant because if you think about it, if I switch the 9 and the 4, I'm really not doing any harm because nothing's actually changing, right? Yeah, when there's negatives in that order thing, whoa, 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 like it's, okay, let's go again. One minute from now, you're going to be in one of 2 groups. You're going to be in a group that is I understand what you just said, and your future is bright, or you're going to be in a group who says, I don't know what just happened, but I'm too ashamed to ask. Please don't be in the second group. There could be a third group where you say, I don't understand why you did that, and you ask. I love that group. I'm going to take my own advice, and I'm going to build my shells, and I'm going to take advantage of what I know. Now, big, huge, big, massive Mongo brain question coming. It's always the signs, man. The signs are the bugaboo. The fact that I look at the back number and it says positive 40 tells me, and I've known this since like 4th grade, that in order to multiply two numbers together, if I gave you a number times a number, and I said multiply those together and get a positive answer, you know that there are, right, you've known for years that your options are non-negotiably a positive times a positive, because that equals a positive, or a negative times a negative. But you also understand that there literally cannot be one of each, right? So it's at this point then that I defer and I say, well, gosh, if you just tell me that they have to be the same, that's really not enough information to satisfy me. Then I look at red arrow guy. The only time I'm really interested in that number is right now, because if he's a minus, there's no way in God's green earth that we're ever going to get that unless we make this choice. Do you agree?
Can't you also just look, and this only works when it's the first number is x to the second, but you can just look what 14x is made of and see what multiplies into 14.
And you just said something really critical, and I wasn't going to bring it up. What you said only works when there's a 1 in front, and so
exactly, it has to be x to the second.
Correct. Yeah. So that's why I'm just going to kind of, I've made the mistake in the past of starting my lesson with these, and people make that observation too quick. And if that gets stuck in your head, then it's years of misery. So remember that that does work, but only under certain conditions. Yes. Mm-hmm. I just heard her say something. Are you okay? Are you? Cooper? Can we finish this problem and then you can show me what you're talking about? I'm interested to hear your case, but I would like to kind of finish this task. And I want to, because whatever question you have, I want to address that. Have we all figured out, and do we understand why there have to be 2 minuses wholeheartedly?
Yes.
And then it's just a matter, as always, of going through your times tables. You just, all the numbers that make 40, 1 and 40, 2 and 20, 4 and 10, 5 and 8. You got to know your times tables, boom, boom, boom. Clearly, what numbers do we want? 4 and 10. Presto, done. Did I lose you? On which part? Oh. Probably for a while. Cooper, what was your question? I'm interested. Yeah. Sure. Correct. If the back number is positive, then this conversation that we had over here is relevant. If the back number is negative, then this doesn't make any sense. Okay, and of course, there has to be one of each. This is the part I don't understand why I'm such a failure at this. It's the number in back that determines so much of what we do. And that's why kids so often go, well, they'll say like, oh, well, the 14 this and the, and I go, no, don't look at the 14. You got to look at the 40. If the 40 is positive, then we'll look at the 14 to determine what they both are. Are they both plus or are they both minus? But if the 40 had been negative in the back, then we just put 1 plus 1 minus and call it a day. Is that what you're trying to get at?
Yeah.
Right. Does this method of factoring seem to be making sense to you so far?
Yeah.
Good. Let's try another one. And yeah, we will probably wind up just having a really long notes day today. So the assignment isn't due till I think like tomorrow night or maybe Sunday. I'm not sure.
All of these that we're doing today are for index, for the primary, for the squared, or
So something has changed in this problem. And Alyssa's on to me. And for the first time now, I feel like we're ready for this. The number that's attached to x squared is not what we call a prime number. And so, you know, I like to sit up here and say, let's take advantage of what we know, right? We don't know much. And the problem with this is the number 4, you understand what a prime number is. You learned that years ago. A prime number is a number that can only be multiplied one way. Like 6 is not a prime because you can do 1 times 6 or 2 times 3. But 5 is a prime because you can only do 1 times 5. Prime numbers become our best friends because they eliminate a lot of the guesswork. The trouble with the number 4 is I cannot sit up here with a clear conscience and tell you, you know, I know this, because I don't. Because yes, those make 4x squared, but what else makes 4x squared? And this will become your least favorite type of factoring because it takes more, it doubles.
Does it have to be the first one? If that-
Yes, and if, listen, you guys have good mathematical senses, a lot of you. And in this case, yeah, I think it's probably going to wind up involving the 4. I don't know. But you start to develop instincts, you start to see things, and you start to be able to maybe rule out in a list of like 24 possible things that you have to check. You and your brain together might be able to knock out 15 of them by just using some good number sense. But you understand at this point that I sit here and I say to you, these are both still in play, right? And so I can say this, going back to Cooper's question, if the number in back is negative, what does that mean? There's one of each, right? And that's, well, just one of each, right? Got to be one of each. So now begins the thing. And the good news for us is the number in back is a puny little pathetic 3. There's only one way to make 3. Well, 2, if you count it backwards, right? So if, let's just say I did something like a 1 and a 3. We know that doesn't work. I think you already understand that negative 12 we got on the outer edge is too dominating, right? But the fact that 1 and 3 didn't work doesn't mean that 3 and 1 doesn't work. So let's check our dynamic. I'll stay consistent with my colors. What does that make, the green thing? What does that make? Negative 4. What's 3 and negative 4 when you add them? Negative 1. And you go, oh, I wanted positive 1. What do I do? So this is 4x minus 3 and x plus 1. Still with me? This is harder than the last problem because not only is the number in front 6 not a prime, so we've got that double set of possibilities, the 2 sets of shells, but 20 is also a poopier number than 3. 3 was like, meh, don't insult me. But 20 can be 1, 22, 10, 4, 5, 5, 4, 10, 2, 21. You got,
It would have to be the minus and times 2, wouldn't it?
no idea. As like I said on the last problem, I can't sit here and look at you and say, like, I know this, because I don't, because it could also be this. And I wouldn't worry about which one has the minus and which one has the plus. You'll notice every time I do this, I just throw them in, and I'm pretty predictable. I always just put plus minus because I just don't care. Because like we saw in that last problem, if we get the right number but the wrong sign, like on that last problem, we got -1, we wanted +1. You switch the signs, no big deal. That's what erasers are for. This is where invariably, if you're someone who struggles with your times tables, you will feel the burn now for the rest of the year, because we need to know that you can come up with the numbers that make 20 or 24 or 32 or whatever, like lickety split. Success? You're really feeling, a lot of you, that what I talked about at the beginning of the lesson, the failure is normal. It's failure, that word makes us feel like we're doing something wrong. If you're missing, you're doing something right, because that means you're in there, you're getting your hands dirty, you're trying things and they're not working and you're erasing them. That failure is good. Every time you miss one, that's one step closer to getting it right. How many of us have it, just with a show of hands? I'm merely curious. 3, 4. Your brain is, you probably know this, adults lecture you about this all the time, but your brain is so much more amazing than you give it credit for, every one of you. And what happens is, when you get good at factoring, you start to see things that you think, how did I do that? And what happens is, if you're still struggling, I want you to look up here. Just for fun, and I'm going to use yellow to kind of indicate that I did this in my mind. If I looked at that and I put a 4 there, that 4 now goes to the prom with the 2, right? Do you agree? And when the 4 and the 2 multiply together, what do we get? 8. And so that's not a big deal in and of itself. But then you say to yourself, well, what has to multiply by that yellow 4 to make this yellow 20? And then it's when it hits you and you go, look what I just did. I just created something beautiful. I made an 8x here and a minus 15x here. And yes, it's not perfect, but it's where I want to be, because the 8 in the middle and the minus 15 on the outside, there's my negative 7. We all know that 8 and negative 15 make negative 7, and you start to see those things before you probably even think that you can. And there's your 8x minus 15x is negative 7x, and you go, snap, I wanted plus 7x. And again, what do we do when we get the right number with the wrong sign? You switch the signs. And so we're going to switch them from plus and minus to minus and plus. And then the number stays the same, but the power shifted to the positive side. As a math teacher, it's amazing the voices that we hear, not in a creepy way, but I'm sitting here teaching this lesson, and I am 100% convinced that today is not the right day to show you any other method for factoring. I will not do it. I feel we're right now kind of perched in a place where I feel like most of you in this room can look at me and say, I know what we're doing. I can do this. And I don't want to mess that up. So I'm going to give you a few more problems, and we're going to keep doing them this way. My favorite way, the brute force trial and error way. And when the time is right over the next couple of days, I will show you the fancier ways to factor. There are ways that involve, that's more complex looking. It's like these little dang diagrams and pictures. But if the time comes where we feel like that's appropriate, then I'll show you that. Today is not the day. And that voice came to me loud and clear. Don't mess this up. So I got a couple more, and then I'll let you start working, okay? You start to love these. If you haven't gotten the memo yet, you will. It'll just come to you. Alyssa got it right away. The fact that there's not a number in front of x squared is of massive significance. It turns the math into such a simpler thing. So in a problem like this, when you build your shells and you take what you know to start with x's, you know they multiply to make negative 72. And you know the only way to make that happen is with a positive and a negative. And what two numbers that multiply to make 72 are we interested in? 9 and 8 for sure.
Yeah, give a negative.
How about I just put, how about I do that? Right?
Yeah, but you could have just done
I certainly could have done the negative first. Yep. Where the bigger number is, where the smaller number is, it's of no consequence. It doesn't matter. At the end of the day, I get x squared minus 1x minus 72. The order of these factors is of no interest to anybody. If your answer was this, nice. It's like saying 3 times 4 as compared to 4 times 3. Same thing. Commutative. Way to use that word, Coop. Ready for last one? I think you guys are getting this, and I'm really, really happy about that. Coy, is all this factoring making your eyes hurt? Is all this factoring making your eyes hurt? A good factorer understands that what's on the TV right now is not something that we are guessing on. We know it's either going to work in the top template or the bottom template, because those are the only ways to make 4x squared. And we know we're not going to have to do any sign changing later, because if they multiply to make a positive 20, they both have to be the same flavor. And if there's a minus in the middle, well, they both have to be minuses. So what's on the TV isn't speculation. And then whatever adult in your life taught you all the ways to make 20, just think of them right now and send them fond wishes through brainwaves and be glad that you know 1, 22, 10, 4, 5, and then it starts happening. So did we get it? What's the dynamic? What works? Yep, the top template is the key. And what happens is, I call this a power play. If I take my 5 and I stick it over here, I've power played the 5. By pairing it across from a powerful number, you take that 5 and you give it a lot of strength. You power play him up, and that's like, whoa, you just made minus 20. You turned huge, which is good, because then the number in the middle is the weakling. And the minus 20 that we made on the outside and the minus 1 that we make on the inside make jackpot. Done. So factoring is that process by which we take a quadratic trinomial and our answer is expressed as a product of 2 linear binomials. Got it? Okay. So,
I'm confused. Maybe this is just like a
of course.
mistake dancing, but how does -1.
I don't even know what I just did. I don't even know.
-20.
You're not confused. Your math teacher has apparently been,
Shouldn't it be,
I think
4x
I got
minus
overtaken
5?
by aliens.
It'd be 4x minus 5, and then times x times 4.
Yeah, what just happened? What just, I just,
Like,
would you, were you guys gonna actually just let me shut the recording off and just sit? Thank you,
no, I was
Alyssa.
just-
I was like staring at it. I'm like, what?
What's wrong with Mr. Ahern? I,
Yeah, I
so-
was like, what's
I will admit that every once in a while I like to make mistakes on purpose. That was not one of those times. I think I got abducted by aliens just now. Did you guys see it happen? Did you? It can happen. I was so confident too. I was just up here just talking and thinking, and I know that was terrible mathematics. Does this work better now?
Yes.
But I still did. I don't take back my power play. I did power up my 4 with my 4 to make it 16. 16 and 5. Woo. It's not that. I'm going to stop the recording. I'm going to give you guys about 7 minutes. That Delta math assignment popped itself in. It should have auto assigned about 15 minutes ago. So, yeah. It was terrible. Now, sometimes you probably shouldn't trust me. I do kooky things.